Hello, my friends of Jupyter Labs. Welcome to this webinar, the webinar of the integration of HEC-RAS with Python. In this case, what we are going to do is that we are going to work with some comms, that is command object model, something like that, that there are some structure of windows that allows us to interact with not only with Python but with any other language with HEC-RAS or with some parts of Windows. Okay. Um, in the description of this video, okay, uh, we have the webinar of Open Read and Open Run Read and on that Open Run and Read output with HEC-RAS models and Python. Okay, the this folder you have to download it from the link, okay, and then you have to place it under your documents. Okay, so if everybody has downloaded the course material and places under your document, please type 2. Okay, if you have downloaded, okay, and then you have placed it there, please type 2. Great. Great. Okay, great. So for us, okay, I'm going to tell you something. Let's see Anaconda. Anaconda. Let's open Anaconda. And here on Anaconda, what you are going to see is that I am going to type, I am going to say conda list, okay? And then I will list all the packages that are installed here on Conda, in the Anaconda. Mhm. So if you have the list, please type 3, okay? And then I'm going to explain some things about this list, okay? There are some package that comes with Anaconda that are inherent to the Anaconda installation, and I think that those are inherent as well to Python. So what does it mean and what I do say about that? That you cannot actually uh, uninstall those packages, okay? So those are really serious, are really conflicted with the installation, so you cannot uninstall this, okay? And the type of package that you cannot uninstall, okay, because I have been dealing with two packages. For example, SQLite. Okay, where is SQLite? Is SQLite, SQL, SQLite. Actually, this is a package that cannot be uninstalled. It comes with an account installation. Okay, and as well, there is another command that is pywin32, pywin32, pywin, pywin32, and this one is the ones that does the magic here. Okay, by some reasons, okay, it could be that your Anaconda is outdated or something like that, and we have or we want to create a common installation for all of us. Okay, and what does it mean that we want a common installation of pywin32? Okay, because maybe you have done something wrong with that, or maybe you have play around with this and it's not working. Maybe it's in another version. So everybody is going to create an environment. So let's say conda env list here, and then we are going to see our environments. Okay, and then we are going to follow. I mean, in case that you are going to follow here, say Katari Labs Conda. Okay, I'm going to follow this tutorial. Well, there are just some commands here. Okay, uh, this is through the chat. Okay, you can play around later. Okay, but it's really easy to create an environment. So Conda create name, and then here this will be Conda create name webinar. So our environment will be called webinar. Okay, so we have created a webinar. I'm going to copy paste this because actually, so then we are going to proceed yes. Okay, then we are going to activate webinar. So we are going to activate webinar. Okay, great. So, and then we are going to install all the geospatial tools. Okay, well, we are going to install Jupyter, and this installs Python, install Fiona, install GeoPandas and Shapely. So actually, this is a whole complete installation and can take some time. Okay, I think that no more than 3 minutes. Okay, and this also installs Jupyter Lab. So with that, we install this. I mean, every one of us will have the same package. So here, okay, and yeah, I will just copy paste this to us. Okay, I will copy paste this to us. Okay, so this will, and it will install GDAL as well. Okay, so it will look for that. Mhm. And will be waiting. If you are here with me, please type 2, 3, 3, 3, 3. If you are here with me, please type 3. Mhm. Great. Okay, my friends. Okay, this says yes because it has to apply, it has to install a lot of package, and this can take some, yeah, it takes less than some minutes, but I think that is worth it because now you know how to use an environment, and now we can assure that every one of us will have the same path, or we have the same installation. Okay, so there are 25 people in this webinar for the 200 people that actually sign up here. I will strongly ask, or I will require, or it will be my intention that you present yourself. Um, well, um, not by their HEC-HMS HEC-RAS knowledge, because I know that some of you will have a great HEC-RAS HEC-RAS knowledge. My HEC-RAS knowledge is not that big, okay? But I wanted to know which is your Python knowledge, okay? So if you are a common Python user, if you are great. I mean, if you do Python 8 hours or maybe 10 hours per day, if you are beginner to Python, or if you are beginner but you want to know more about the special tools, or machine learning or whatever. So just tell me that. So for example, just by your name, for example, so and then your name, your country, or the city, because we want to know, and then I want to know a lot of cities. I mean, not only the country. Lima, Peru, and then the your level in Python. So it's advanced Python level. Okay, so please break the barriers of the please break the barriers of this internet connection and just present yourself in this way. Don't be shy. So here we are. Okay, so don't be shy, just present yourself through the chat, okay? And just to remember that if you don't present yourself, I will close this connection. Okay, so Nekati actually um, has saved the connection. Sweden, Algiers, basic, yeah, Kalmar, yeah. Okay, who else? Yeah, from Brazil. Okay, from Curitiba, beginner to intermediate. Okay, okay, from Poznan, difficult to define. Yeah, basic Python land. Uh, wow, there is I with 20 years of Python. Okay, intermediate, basic, from Lima, zero level. Okay, that's also level. Okay, great. So now what we can do, okay, so we can um Dresden, Brazil. Is Dresden in Brazil? There is a city in Dresden in Brazil. Okay, so manage. So let's see CD documents. So here let's shift so CD documents, and here let's shift to okay, great. Um, let's shift here to the webinar on okay, great here, and then here we are going to launch Jupyter Lab. Then here we are going to launch Jupyter Lab. Jupyter Lab. That's why the webinar folder has to be on your documents, okay? Because this is being launched from one folder up of your document. So if you are here, please type 4. If you are here, please type 4. 4. Great. Okay, so this is what we should have. So this is the model, that there are two models and there are some scripts here. Okay, great. So this is, if you have this in your computer, please type 5. If you have this on your computer, please type 5. Great, Andre. Actually, you should see something like this. I mean, if you are a fully beginner, you should see something like this without the Julia, because actually Julia was not. Yes, yes. Okay, so let's see. Yeah, okay. What is the problem here? The problem here is that you need to have HEC-RAS installed. So here we have HEC-RAS. In my case, I have two HEC-RASes. HEC-RAS. I have HEC-RAS 6.3. Okay, but like you can have HEC-RAS 5.07. Okay, so and I think that it can work with both of them. Okay, but okay, I think that it can work with both. So we are going to create a new notebook here. The new notebook will be called rename notebook, and this will be called part one. Okay, and the scripting of this, and this has surprised me is that it's so simple to control HEC-RAS. Okay, it's so simple. I mean, on the setup, because just here you have to do import win32 com.client. Okay, great. So HEC is equal to win32 com.client.dispatch. Okay, and then here I have RAS. In my case, I have HEC-RAS 6.3. So I will add this 630, okay, dot HEC-RAS controller. Okay, and that's it. If these cells run, congratulations, you have completed okay, you have 50% of everything done of this webinar. Okay, if you are here with me, please type 7, 6, 6. Great, Andre. Okay, great, Tomás. Great, Vitahaya. Vitahaya. Okay, who else here of 25 people connected? Just 3 people. Who needs more time, let me know. And then if you have any question, like you can also play it. Great, Raquel. 3 guys, 1 girl. Yeah, it's always in my webinars there is more guys than girls. I don't know why. Okay, who else? Who else? Please tell me. I mean, yeah, and this is something that also happens in the webinar. That there are a lot of people that are just watching the video. Yeah, and yeah, that's not that fair. I mean, like, well, you are encouraged to take this, but in my personal opinion, this is the life experience where you can try and then you can fail live. Okay, so and this has a word and this has a value. So try to do the exercise. Okay, great. Okay, okay. So yeah, just say okay, yeah, you need to have HEC-RAS 6.3. I mean, if you have the another version, for example, you have 507, you can this is the controller of 507. In my case, I have 630. Okay. Okay, great. Great. So here we are going now we okay. For example, we can create some commands like, for example, we can say hex show ras. Okay, so we can with that we prompt the HEC-RAS interface here with just this command. Okay, with that we prompt the interface. Okay, with that we prompt the interface, and actually you can close it and nothing will happen because this command only opens that. Okay, so if you close, it's up to you. Okay, so let's see. Let's say import OS. Okay, and then say test one path is equal to os dot path dot apps path of model, and then say test one, and this is test one dot prg, that is actually the project. Okay, so this is test one path. Okay, I haven't tried that. I haven't tried, but I haven't tried to open a project on relative paths. Okay, and why I haven't tried to open a project on relative paths? Because this is a COM, so this is an API that is actually somewhere on the Windows. Okay, so and this API might not find your relative paths because it's actually working something else. But the absolute path, this it will be easier for the API to work with. Okay, if you are here, if you have understood me, what I have done, so please type 7, 7, 7. Great, 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 great. Okay, so say heck.project open. So we can open our model, test one path. So we can open that. And then what happened? I mean, nothing happened. No, no, no. We have already happened. If you see here, all your project has opened in the HEC-RAS interface. Okay, that is great. Okay, so and well, you can look for the geometric data. You can look, okay, well, this is part of the simulation that is already done. Okay, this part is also the simulation that is already done. Okay, but what we can do is that we can simulate, yeah, that we can uh, compute the model. Okay, we can compute the model and say simulation one is equal to HEC.compute current plan. Okay, and these are related to the message, okay, that we will prompt, okay. Um, and then with this command, we can compute our HEC-RAS model, and this will be computing the HEC-RAS model. Mhm. So it will be computing the HEC-RAS model. Okay, so it will have computed the HEC-RAS model. Okay, then, okay, I will tell you that all, okay, have you seen that we have imported any HEC-RAS package? No, we haven't not imported any HEC-RAS package. So this, okay, this process, okay, el compute current plan, project open, and the show RAS actually come from the com, okay, the com. Okay, so it's Windows com. What is Windows com? Definition. Mm, com API definition com component object model definition. Okay, so if you want to see more about this type of structure, this is the link. I mean, this is how it's been working. Okay, it has a lot of, this is related to the interoperability of certain programs in Windows. Okay, and this only works in those only works in Windows. Okay, I don't know if those works in Linux. Okay, so we see heck dot and HEC-RAS has this com. Okay, while HEC-HMS do not have those coms. Okay, so we have project save. So we can save the project. Okay, and with that, if we go to our model, okay, test one, okay, and this is test one.prg, and is, well, to me, we are at 11 a.m., 11:30. Okay, so this is, we have saved our project. Okay, so that's great. So, and then we can quit from the software. So I say quit from the software, quick RAS, and then okay, and then if you have seen, there is no more HEC-RAS here. If you are here with me, please type 8. If you are here with me, please type 8. Who else is here with me? If anybody is experiencing some problem, let me know. Okay, great. For any of you, all of the code is actually here on the script part of the code. So if you are behind or something like that. And then we have a guy that has the question that I was looking for, and then I will let the people from this webinar to please answer that question of what I have said at the beginning. Okay, so let's see, and let's add. another notebook that will be, please answer Nabil, because he wants to know, because it's the same question in every webinar. I mean, great, great. Yeah, I mean, it's for the, well, this was not the worst webinar, but there were another webinars that the only question of the whole webinar is it was that the webinar will be recorded. I mean, and yeah, for the teacher, it's kind of hard to see this kind of interaction. Okay, thank you, Raquel. Okay, so let's see. Import OS, import win32com.client. Okay, so import numpy asnp, import pandas as pd. Okay, great. So we have imported all our packages. Mhm. And then we are going to open our controller. So I say win32.com.client.dispatch, okay, of RAS 630, because in my case it's RAS 630, HEC-RAS controller, okay, rc.show RAS. And for the people in Brazil, like after before the COVID, I plan to go to Brazil to do some, ah, this is point. I planned to go to Brazil to do some webinars and so on. So yeah, however, after a while, after the COVID, the situation got a little bit complicated because now I have two kids. So I have like any trip will be much I mean, I have to travel with with my wife and my kids. So, but um, let's see, or like if you want to drop some ideas about which will be the topics that and the cities that you are going to that you will see that will have bigger audience. Uh, Let me know through the chat, okay? Or like kind of the universities that will host those events as well. So let's say test to path. Okay, so we are going to create a os path dot apps path model and then say test2 and the prg is s7.prg. Okay, chief enter, and then say chief enter is the same as rancel. Okay, it's the same. So say an rc dot project open and say test to path. Okay, so we open the project and then you will see here that the test2 will be open already. Okay, and now we are going to get some information. Okay, I'm going to get some information about, there is a question about is Asani that cannot open HEC-RAS, and then please Asani, if you can, you have to look for this number, because in my case, okay, I have HEC-RAS 6.3, so it's 630. So if you have another version, for example, you have 5.07, you have to insert here 500, 507, okay, without the point. Okay, great. So let's see and let's open and let's get some information. So for example, let's say get is equal to rc.geometry.get rivers. Okay, great. So it will be okay. So if I open river, I get this. This is a tuple. Okay, However, I am more interested in just extracting just the name. I mean, if I want to see, I will do some slicing here and the result will be just river. Okay, if you are here with me, please type 2. If you are here with me, please type 2. Okay, great. So rc.geometry.getRiches 1. Okay, so geometry get riches. So rich uh, is actually get in riches. You have to give the first. Okay, because if you open that, if we go to geometric data, okay, so we have one river, yeah, that is also have one reach. But in the case of the reach, okay, so you have to specify the, for example, the reach. So the reach one is the one selected, okay, and it starts from one because by default Python starts from 0. And then if I just want the value, that will be, okay, the value of reach one. Okay, great. And then I can get the nodes. For example, here I have some nodes that goes from 3900 to 100. Okay, so I can get the nodes. I can get the nodes. Nodes is equal to rc.geometry. Okay, If you are here with me, please type 3. Okay, what I have done here. Okay, for example, if I type geometry G and then press tab, it will show all the methods that are available that start with G. Okay, but if I type RC, just RC, it will show all the methods related to the COM. I mean, these are all the methods that are implemented through the Windows API that can be accessed through Python. Okay, in our case, it will be uh, get nodes. Okay, get nodes one. Oh, and what does it mean one? Because it's the river one and the rich one. Okay, so if I use these nodes, okay, but I want to see just the list of the nodes, yeah, and this is a little tuples, and then I am going to list of nodes, okay, and then I will show just the first 5 nodes. So it will be the 3909, 3665, and so on. And then if we go here, so it will be the 309,001, 306,065, and so on. Okay, so with that, uh, the doc of the, what is the question? The doc of the methods or the doc of the methods? Yeah, okay. Any documentation of that, so you have to use for, I haven't looked for that, so I just HEC-RAS com interface. So HEC-RAS feature. No, HEC-RAS com. HEC-RAS Win32. RASCOM objects. You can look for the HEC-RAS manual. Okay, and then for example, let's say geometry get rivers, nothing. Frustrating. But if you want to know more about some, there is a limited, there is limited support by typing. Okay, so at least you have here the arguments, and then if you want to use help as well, that might work, but it's also the that. Okay, okay, so that's it. Yeah. Right, so these are the nodes. Okay, so we are going to create, for example, un manning for the channel is actually 0.029, okay, and a manning for the banks, for the river bank is equal to 0.035. Great. So, and then we are going to apply these values to our, I mean, how will it will be? So I say for E in range of the 19, because those are 19 nodes. Okay, say var man is equal to rc.geometry set man, okay, lch. Okay, there is a to completion none river reach, okay, nodes, okay, the node, okay, and then we apply man bank, man chunk, the manning of the bank, the manning of the chunk, and the manning of the bank again. Okay, great. And with that, we have applied and then we have changed the manning values for this. Okay, by applying this value. Okay, something that I don't know. Okay, something that I don't know, that if I open this on the cross section, somehow the the manning value is still the same. Okay, so it's 0.025 and it haven't, okay, so but the command didn't haven't provide any error on that. Okay, and as I see, the manning values here are blocked. Okay, this is actually, okay, this is just to show this command, but beware that you have actually to look that this is creating some, to look, you have to check that is creating some uh, that this is creating some values, some changes here. Okay, right. So yeah, let's see. Great question from Isamine. Okay, let's see if there are some values for the whole setman. Okay, let's see. River reach. hmm? River reach because RS. Okay, so el river reach RS. Okay, so in setman, so you have river reach. Okay, and then you have nman, number of mannings. And this is something really strange. Okay, let's see. Okay, let's see that if I do this, what happens? En man. A ver, let's see. I don't know. I mean, Manbank, mm, River Ridge. Okay, well, let's see this. No, actually doesn't work. And what happens if I don't use this? So if I go here to the another station, 0.29, 0.29. So it has applied. So if this is 31, it's changed, but it changed for all of that. Okay. Okay, it's doing the change, but it's changing for all of that. Okay, don't know why. Don't blame me. Okay, if you are here with me, please type 8. Who else is here? Okay, so here we can do project save. Okay, great. So we are going to compute our simulation. Simulation dot is equal to rc dot compute tab. I always use the tab current plan of none true. Okay, great. So this is the simulation and it's actually simulating. Okay, it's making the simulation. Okay, it has finished, so we can close. Great, that's great. So what we are going to do is water list is flow list and veloc list are equals to 3 empty list. Okay, if you are here with me, please type 9. If you are here, please type 9. Great. So now what we are going to catch is the water, the flow, and the velocities for each node. So let's see, shift enter. Let's say for E in range of 19. Let's say water is equal to RC dot output node node output, and let's say 1 E plus 1. So this is the river 1, the ridge 1, the node 1, because actually the range starts from 0. Okay, none, okay, 1 and 2. Okay, this is the slicing, and then you have to search over the, I mean, if I were you, uh, well, you have to see the structure of the output. Okay, so let's see, I mean, I will, if you want to see, if you want to explore this, for example, I will do, okay, say, okay, how do I explore this? So you just copy paste this. Okay, so it's a river down, down, okay, UDN, and then you have the, okay, that's it. Okay, So as you have seen, the documentation is not that clear, but okay, good luck on your research on this. Okay, and then we see the flow is equal to rc dot output node output. Okay, but in this case it's the same. However, is the set 9. Okay, in this case is the set 9. Okay, the number of variable of flow is the 9, the number of variable of the water level is the number 2, and the speed is the velocity. The veloc is equal to node output is the number 23 and 0, and say water list dot append water flow list is equal dot append of flow, and veloc list is equal to append veloc. Okay, great. If you are here with me, please type 1. So we have created 3 lists. Okay, the water list, the flow list, and the veloc list. So you can explore any list. You're my guest. Okay, this is the water table list. Okay, that goes from that that um, that where the water table decreases for 7 meters on the all the path. Okay, great. So now what we are going to do is that we are going to create a data frame. So how we are going to create a pandas data frame? Output is equal to cross sections. Okay, great. Then say water surface elevation of water list velocities of ms is equal to veloc list. Okay, great. And then with this, we create a df is equal to pd dot data frame of output, and then say df dot set index of cross sections. Okay, so the cross sections, and there is auto completion, and I always type the auto completion when this is possible. Okay, so here is if I use df dot head, this will be sorry sorry, df is equal to df set index, otherwise it won't apply the change. So here we have the cross sections, here we have the cross sections, okay, and the water surface and the velocities. Okay, for I mean just the head because there are the first row, but it actually has all the other rows. Great. So if you are here with me, please type 2. Great, you are doing amazing. Huh? Okay, great. So now what we are going to do is we are going to do and to compare a graph from HEC-RAS to a graph created by Python. So I say import matplotlib.pyplot as plt, and then say plt dot figure of fig size is equal to 12.5. plt dot plot of water list. We can line style color is equal to b, label is equal to water surface elevation. plt dot grid is equal to true. plt dot x label is equal to progressive. plt g label water surface m. plt dot legend, okay, and plt dot show. Okay, great. So that will create this profile of the water table over the model. Okay, and then if you are here with me, please type 3, because the last step that we are going to do is to couple this with the, or we are going to compare this of uh, what will come from the HEC-RAS. Okay, who else is 3? At least I wait for 3 other people, okay, to go from. Okay, one more. Great. Okay, so let's see and let's compare that to the HEC-RAS. So we go here to the general profile tool, and this is velocity, no, and this is elevation, uh, with flow, no. Mm, and that this is okay. So here is the channel distance, and this is the ground elevation, and then here on variables I'm going to plot the water table, water surface, but profile, clear all, okay. Okay, so this is the ground, and on profiles we are going to the profile one. Okay, so this is the as well. So this starts in 200. Hmm? This starts in 2447 and ends up in 2440. Okay, the same as here. But it's in the other direction. Okay, so with that we can compare, and as well as we have here just taking the water surface elevation, you can take the speed, or you can take the depth, or whatever might be of your interest. Okay, so if you are here with me, please type 4. That will be the end of this webinar. I don't know if you have any other questions